So start the recording because today we are talking about angle relationships. So here we go. All right. I assume you can see the slideshow at this point. Yeah?
Yeah.
Good. All right. So angle relationships. This is where we actually get into what would be more traditionally considered like geometry as we start to go proofs and things like that. So that's where we're going next. In this case, we've already been talking about lines. We've already talked about angles. In this case, we have A, B, C, D, and E. Okay, I want to know, somebody label me, what is this angle right here? What is the name of that angle right there?
Loud.
Acute.
You hear him?
It does happen to probably be acute, but let's actually label it with the three names like we did in our delta math for today. So what are the three letters that are required here?
A, B, and E.
A, B, and E. So in this case, angle ABE, or we could say angle EBA. The only thing we couldn't do is we can't do something like AEB because B has to be in the middle. Now, I want to know what's this angle over here. What's that one on this side called?
ACD.
What is it?
DCD.
DCB?
Yes. No, because B has
I
to
said
be.
B has to be in the
I said-
middle.
Yeah, CBT. DBC, CBT.
DBC, okay. DBC I'll take, or
CBD.
CBD I will take. Both of those because again, B has to be in the middle. Now, what do you think is true about this angle and this angle right here?
Equal.
They're equal. Now, let's talk about that word equal. Equal is this. Equal means 3 equals 3. If somebody is looking in a mirror, they are equal to one another. However, if we have people that are twins, are they actually the same person?
Yes.
If they're twins, they're the same person?
No.
No. Do they normally look quite a bit alike?
Yes.
Normally. So we would call these congruent because same size, same shape, but not exactly the same person versus if somebody's looking in a mirror, it is literally the same person. So equal would be ABE is equal to EBA because it's literally the same angle. However, ABE and DBC would be congruent. And so that's going to be a key definition that we're going to have to use throughout the rest of the year. And by congruent means same size, same shape. So somebody estimate how big this angle is. Just an estimate.
60.
60, somebody said. I heard 60. So how big is this one?
60.
Good. Okay, good. Now, here's another question. Does ABD make a straight line? Yeah, ABD is a straight line. So somebody tell me how big this angle is. ABC. How big is ABC? Well, here's the thing. A straight line is how many degrees? A straight angle, according to last night's homework, was
80.
180. If I know this much of it is already 60, what can I do? Yeah, subtract 160. The answer is 120 for this angle. Now, question. Is EBC a straight line?
Yes.
Okay, so does 120 and 60 still work here? Does 120 and 60 still make 180?
Yes.
Yeah.
Yeah, which is why These angles right here are called vertical angles. They are not vertical because they're up and down. What is this point right here in the middle called for each angle? The point where the angle turns around.
Midpoint?
Ooh, close. Only if these were segments. Vertex. That's where the vert from vertical comes in. This is the vertex. So they're connected at the vertex across from each other. These are vertical angles. So that's what your Ed puzzle is going to be about this evening. That's what your Ed puzzle is going to be about this evening. Let's go ahead and roll over here to Delta Math. And if I go to Delta Math, log in, okay. And we have identifying angles and investigating vertical angles with a protractor. So let's do a protractor one. Move the yellow dots in order to make the segments intersect. Which point do I need to grab to make them intersect? Pick a point. M. Do they now intersect?
Yes.
Yes.
Good.
Thank you.
Let the intersection point be called N. Make the lines intersect in such a way that KNM is an obtuse. KNM, is that obtuse? Is this angle here obtuse?
Yes.
Yeah, looks good. Greater than 135. Yeah, that's greater than 135. You say, I don't know what 135 looks like. Well, do you know what 45 looks like? Let's think about this real fast. We know that's 180 degrees. We know if we make a right angle, how many degrees is that?
90.
90. So if this is 90, where would 45 be?
Right in the middle.
In the middle. So 45 here, 45 here. Very good. So if this is 45, 180 minus 45, 135 would be what's left. Likewise, if I said find a 60-degree angle, where would 60 degrees be? If that's 90, where's 60? More or less angle than 45? If this is 45, 60 is going to be more or less than that? 60 compared to 45.
More.
So that's 60. If this is 90, how much is left right in here, guys?
30.
30. So do you notice all we're doing is a little adding and subtracting? It's not really rocket science here. But why is it that Mr. Moore makes you write down all of your work and draw all the pictures? Because you got to be able to visualize it. So bigger than 135. Afterwards, use the protractor to determine the precise measurement of all the angles. You should draw lines if K and M are not the proper size. Okay, I'm done moving my lines. So here we go. This degree is how big?
8.8.
Whoop. 156. All right. So JNL, right? Is that JNL?
Yeah.
Come on. There you go. Okay. JNL was 156. JNL 156. All right. JNM. JNM. What do you think?
24.
Good. Now, by the way, could we have probably guessed that?
Yeah.
Because what's true about those two? Have to equal how many degrees? Well, does this make a straight line, ladies and gentlemen?
Yes.
Yeah, it's 180 degrees. So whatever this is plus this should be 180. Now, you can go over here, can measure it. Shockingly enough, what's this little angle going to be? LNK, LNK, K and L. Well, say I can't see it. Well, but what was this one over here?
24.
So how big's this one over here?
24.
Oh, okay. And how big's this one going to be?
556.
There you go. Do you see very quickly that vertical angles are going to save you a ton of time? Now, for those of you that weren't either A, paying attention, B, didn't care, or C, just were not there yet to follow along, how can you figure out how to do this problem tonight when you get home and go, I was really confused on how to do the problem? How do you do it?
Watch the, oh, yeah.
That's it, because will it literally do exactly what I just did?
Yeah.
Yes, it will. Okay, identifying angles terminology. Which angle number represents an adjacent angle to AGD? AGD. So AGD is angle 3. What angle is adjacent to angle 3? What's the word adjacent mean?
Right next to you.
Right next to. So for example, you know, the junior high is adjacent to the high school. It's right next to the high school. So which angle here is adjacent to angle 3? Is it angle 6? Are 6 and 3 adjacent? Are they next to each other? No. 4 and 5 would be. So in our case, 3 and 2. Geometrically, for something to be adjacent, it has to share a side. These two angles have a side that they share. So where one stops, the other one picks up. That's adjacent. All right. And is there, I believe there's a third one we need to do.
Yes.
Angle terminology with equations. Angle terminology with equations. Ah, here we go. What does it say about angle A and B? What does it say they are?
Vertical.
Vertical. So angles are vertical. Is this a picture of vertical angles right here?
Yeah.
Yeah, those are vertical angles. So if those angles are vertical, and it says angle A is 5x plus 6, where's angle B? If it's vertical, where's angle B?
The other side.
The other side, 6x minus 25. Because they're vertical, what's true about those two statements? Because they're vertical angle, what's true about these two angles right here? They are
Well,
equal. So can I say 5x plus 6 equals 6x minus 25? At this point, can everybody solve that and get x by itself? Yes or no? Good. Now, if I just put the answer for x in here, is it going to count it right or wrong?
Wrong.
No.
Oh, wait, no, right.
In this case, it says find the value of x. That'll be just fine. Could I have exactly the same problem, but it say find the value of angle A?
Yes.
I could, and you just have to plug it in. The kicker there is reading, reading, reading. Okay, ladies and gentlemen, this is a little bit more challenging than last night's homework, but frankly, not much. It's just going to take you more time. What should your page look like when you turn it into Google Classroom? Every one of these is going to have a what with it. Picture, drawing. Yeah. If you turn stuff in today without a drawing, it will receive 0 credit. Get the idea?
Yeah.
All right. So make sure that you are putting your drawing in there. Make sure I can see your algebra. All right. So what questions do you have at this point?
Any questions? I don't think so.
All right, other thing to think about is tomorrow morning, 8 a.m., I run grades. So make sure that all of the missing work that you have is already put in by tomorrow morning at 8 a.m. You have plenty of time to work in class today. Get after it.
All righty.